Determine the domain of the function. We've got a function k of x, and it's given by the formula 2 over x minus 3 plus square root of 8 minus 2x. All right, now when you read functions and you're trying to do things with their formulas, a good eye to have on everything is to sort of be able to break them down into different parts based on sort of basic arithmetic operations. So when I look at this, yes, this is a big formula, but I also see, look, there's clearly a distinct part over here that's got a division, plus this other part over here that's got a root. And of course, if you want to go further, the division has a top part and a bottom part and things like that. But being able to break a function down into how it's made of smaller, simpler functions is a very good skill to have, especially when it comes to finding the domain. So what we have here is a function with a formula that's based purely on arithmetic operations: addition, subtraction, multiplication, division, and we also have roots here as well. Roots are one of the arithmetic operations. So when I think about finding the domain, I think, okay, there are certain things with arithmetic that are not allowed, that don't make sense. Division by 0. Okay? Taking a square root or an even root in general of a negative number. Taking a logarithm, this question doesn't have logarithms, but taking a logarithm of something that isn't positive is also sort of forbidden. So when we look at each individual part, 2 over x minus 3, you can plug just about any value of x in there, and that piece will make sense. It'll have a value. The only time you can't do that is when the bottom is 0. Okay? So what's not allowed? You can't have x minus 3 be equal to 0. So x minus 3 needs to not be 0. So as long as x isn't 3, you'll get a number here that you can add to the number that we get here. So now let's look at the other piece that's got the square root, because square roots also have sort of a restriction. So we've got square root of 8 minus 2x. Now you're not allowed to do what under an even root? By the way, if this was a cube root, we wouldn't have a problem, or a 5th root or a 15th root, but because it's a square root, an even root, we have to say, well, hold on, the thing under the root can't be negative, right? Can't be negative. It has to be positive. Not just positive, it's got to be greater than or equal to 0. Okay? So that tells us more about the values of x where k is defined. Now we can use our knowledge of inequalities to rearrange this. We divide by 2 on both sides, and we get the inequality is not going to change because 2 is positive. And we say, oh, okay, great. X has to be less than or equal to 4. And so what we do is we combine these two facts. Okay? X has to be not 3, but less than or equal to 4. Sometimes it's helpful to use number lines to visualize this. Let's draw a better number line. You certainly don't have to, but all the activity is sort of around 3s and 4s. So let's put 2, 3, 4, 5, 6, and things like that. 1. Okay, so now the first little bit of information, x can't be 3. Okay, so there's a hole there. It can't be 3. Okay. Anything else is fine. Any other number is fine. But we also have x has to be less than or equal to 4. So we can have 4, and we can have anything less than it, except for the 3. We already threw out the 3. Okay? But any other number less than or equal to 4 is fine. So this is a visual representation of the domain of k. So I'll write dom k, dom for domain. And what is it? And there's lots of ways you can write this. If you wanted to say set notation, you could say it's all the x's, so that x isn't 3 and x is less than or equal to 4. I prefer something like interval notation. Now with interval notation, we have to look at it. There's two pieces. There's everything less than 3. So negative infinity up to 3. We use a round bracket because it's not 3. Or there's the stuff that's bigger than 3, because 3 is excluded, but that's less than or equal to 4. So 3 up to 4, and we include 4, so we use the square bracket. So I would probably prefer that as my answer. Nice interval notation there for all the x's that make k work. But there we go. There's our final answer.